Okay, finally it's time to talk about part E. So D, I'm looking at an old version. I have h of x is equal to tan x. So this one is actually going to be surprisingly simple. H prime of x is equal to secant squared of x, which, by the way, is 1 over cosine squared of x. And the thing we need to keep in mind about tangent is where it's defined. So we might look for critical points and say, okay, when is cosine squared of x equal to 0? Well, that happens, these arrows are going to say if and only if cosine of x is equal to 0. Because if the square of something is 0, the only thing that if you square it you get 0 is 0. So then you get x equals pi over 2 plus pi k. So if I look in this interval of minus pi to pi, I get minus pi over 2 and pi over 2. And that works out. But the thing I have to remember about tangent is those are going to be vertical asymptotes. So that's basically the issue. But we're actually going to see this when we do our sine chart, because if I have cosine of x squared for h prime prime, or for h prime, if I go minus pi over 2, pi over 2 to pi, well, this thing is a square, so I always get a positive number. So tan of x is always increasing. Increasing on minus pi, and that's a hard bracket, minus pi over 2, together with minus pi over 2 to pi over 2, together with pi over 2 to pi. Increasing everywhere. And now let's take a second derivative. H prime prime of x equals, so I had 1 over cosine squared of x. So this is the derivative of, I can call this cosine of x to the minus 2. And the reason I might do that is so that way I can do a pretty simple power rule and chain rule. So this is going to be minus 2. Leave the inside alone by chain rule. Cosine x to the minus 3 times minus sine of x. And I get 2 sine x over cosine of x cubed. And now we look for zeros on this. Where does that happen? Either sine of x is equal to 0. It's where I get x equals pi k, or cosine x equals 0, which is pi over 2 plus pi k, giving us the same zeros we had. And now we do all these in a sine chart. So minus pi over 2, 0, pi over 2 to pi, sine, cosine, cubed. And cube is an odd power, so we know that we're going to have, anywhere cosine is positive, cosine cubed is going to be positive. And anywhere cosine is negative, cosine cubed is going to be negative. So that's not too rough. So sine of x. From 0 to pi over 2, it's positive. And again, I don't need this extra. If it's less than that, it's negative for cosine cubed. If I'm on either side of 0, I'm going to be positive. Again, you could do this just by plugging in. So say from 0 to pi over 2, you plug in pi over 4. From 0 to minus pi over 2, plug in minus pi over 4. Here you'll get minuses, so you get plus, minus, plus, minus. So I get it constantly changing where it's concave up and concave down. So concave up from minus pi to minus pi over 2, together with 0 to pi over 2, and concave down everywhere else. Minus pi over 2 to 0, together with pi over 2 to pi. And if we think about the way that tangent looks, that makes sense, right? Because tangent, one period of it looks something like that. So everything we have agrees with that.